He didn't last very long. He was so good yesterday. Oh, yeah. And he didn't really appreciate that ice
Okay, let's go to 7.2 today. I imagine you had too much trouble with 7.1. Okay, absolute value functions. So today, we're going to begin the graphing portion of this section. Now, an absolute value function is a function that involves the absolute value of a variable. The graph shows some of the functions and the related absolute value functions. To graph an absolute value function, so make a note of this right below those graphs. It's going to tell you how you want to graph it. So there's 3 quick steps in how to do this. To graph the absolute function, make a table of values and then graph the function. That's method number 1. Use y equals f of x and y equals negative f of x to sketch the function. That's method number 2. For y equals negative f of x, all negative y values are reflected in the x-axis. That's method number 3. So I'll do all 3 in a second. To analyze an absolute value function graphically, first graph the function, then identify the characteristics of the graph such as the x-intercept, the y-intercept, the minimum values, and the domain and range. You can write any absolute function, y equals absolute value f of x, as a piecewise function. Okay, so before I get any further on the piecewise, the piecewise was something that we used to do in grade 12, but they brought it down a little into grade 11, and it's just basically for the absolute value. So what it is you take 2 graphs, and you take parts of both graphs in order to graph it. And actually, that's what happens with an absolute value graph. So the best way we can look at this is, let's graph an absolute value graph. We'll do it with all 3 methods that they show you, and then we'll talk about the piecewise part after the fact. Fair enough? Okay, so the first thing I'm going to do, I'm not going to start with the one in the book. I'm going to do one here first. So y equals, or I guess we should probably do, because we're talking about functions, f of x is equal to the absolute value of 2x minus 4. Okay? So I want the absolute value of y equals 2x minus 4. Now, first way you can do it is randomly select a set of values for x and then draw y. But if you look at the absolute value graph, let's say, just take a look on that page 285, that graph on the right. You notice the graph on the right comes to a point at the bottom. It's very similar to a parabola in the sense that you have a minimum value on it. Okay? So what I would do is I'd try and find out what that minimum value was, and then I would find the x values to the left and to the right of it to graph it so we get a look at it. Because if you select randomly x values, you may not get an actual look at the graph that gets you the look that you want on the graph. So here's what I'm going to do first. I'm going to do method number 2 first. I'm going to graph y equals f of x first. In this case, y equals f of x, I'll graph this part of y equals f of x, and I'll do the absolute value after. Okay? So the first thing I'm going to do is draw a line. So okay, so I want to graph y equals 2x subtract 4. How do I graph y equals 2x subtract 4? What do I do? Remember how to graph a line? What are the 2 parts of that line that I get from the equation?
The y-intercept.
The y-intercept and
Slope.
slope. What's the y-intercept?
-4.
-4. So I start right here. And what does my map tell me to do? Up to right 1. So I go up to, and I go right 1 to right here. And then I draw my line. Okay. All right, so there's that. Okay? Problems? It's just a graph of a line. Okay, we've done this since probably grade 9. So up 2, grade 1, actually I only went up 1, so I should have been right here. Okay, now, by definition, what did we learn about absolute value yesterday?
It can't have a negative.
Can't have a negative, right? So any negative y becomes a positive. Agreed? All right. So, what was my y value on this graph right here?
-4.
Negative 4. What does negative 4 become? Plus 4. So, 1, 2, 3, 4. Change the color. So it goes right there. Okay? This, right there. This, right here. This, right there. This is how my absolute value graph looks. Okay? So, method number 3 says you take the y values that are below the x-axis, all the negative y's, and you reflect them. Now that's an important word for you because at the start of next year, we are going to do transformations of graphs. And there's 4 transformations you can make. A stretch, okay, a compression, a reflection, which means that you flip it over a certain axis, and then you have a phase shift and a vertical shift, which means you move it left to right and up and down. The first word that you want to learn is reflection. Reflection means that you flip it over an axis. In this case, I'm flipping it over my x-axis because I'm changing all my y negatives to y positives, because that's what absolute value does, and I flip it up. So there's my graph. What is my x-intercept? 2, right? What's my y-intercept now?
4.
4. What's my domain?
Infinity to infinity.
Excellent. Or, how else do we say that? X is an element of all reals, right? Because it goes up and out forever. Remember, domain, how far left does it go to how far right it goes? And if it's got arrows on the end, it means it goes forever left and forever right, correct? Okay, what's my range for this graph?
Y is greater than or equal to 0.
Y is greater than or equal to 0. 0 to positive infinity. So everybody remember that now? Okay, great. So that's it. That's what you have. Now, if I were to do a table of values, I would start with my x-intercept, because that's the vertex point, right? That's as low as it's going to hit. So I would start with that. So what is that coordinate? 2 and 0, right? Now I'm going to go 2 to the left, 1 and 0. I'm going to go 2 to the right, 3 and 4. So let's start by putting 0 in for x here. 0 times 2 is?
0.
Subtract 4 is? Negative 4. Absolute value of negative 4 is? Plus 4. 1 times 2 is? 2 subtract 4 is? Absolute value of negative 2? 2. Good. 3 times 2 is? 6 subtract 4 is? Absolute value? 8 subtract 4 is? Absolute value? What do you notice? It's symmetrical, isn't it? Just like our parabola. It's exactly the same to the left of the vertex as it is to the right. That's what an absolute value does. So you can randomly select these x values and plug them into your y. You can put it on your graph, on your calculator, and get a table of values. Or I like to graph that point first, find out what that value is. So I put 2x minus 4 equals 0. Solve for my x-intercept. In this case, it was 2. All right, and then I went 2 to the left and 2 to the right, and that gave me my shape. Does everybody understand that? Okay? Alright, so then there's one more thing. And that's that piecewise part. Okay? So this is the part that gets confusing to you. So I'll try and do this as best I can, and then we'll work through it. And again, we don't need much on this because we don't do it in grade 12. So it's just a case of learning it here as to what it looks like. Alright? Now, here's how this works. This line right here. The equation of that line was this. Agreed? Okay. Now on my on my absolute value graph, using the domain, pay very close attention to this. Using the domain, the x-axis. What part of this whole line did I use?
Part of the x-axis.
No, but so what I'm saying to you is from the domain part of it.
The positive.
Okay, keep going. You have to be very specific here. What part of this line across this axis did I use?
Positive. To the positive infinity.
Yes. Right? I used that. Agreed? Everybody's okay with that? All right. This graph right here, if I extend this line now, the equation of that guy is that. The negative of it, which is negative 2x plus 4. We all agree? The y-intercept's 4 on that one, and it goes down to right 1. So that's my slope, right? We all agree with that? Okay? From this line, what part of the graph did I use? Y is, I'm going to just use less than, because I used the equal to up here, so I can do it for either one. For the record, just do it for one though. Okay? There it is. I explained my graph using two separate graphs. That's what piecewise is. Take the positive graph, so that was just 2x subtract 4, and then the negative of that equation, so I put the negative right in front of it, the entire equation. And I explained what part of it I used. I only used y is greater than or equal to 2. I only used that part for this graph. Yes?
Why is it y and not x?
Oh, it should be x.
Jeff,
I don't know why. Thanks, man. Thanks. Well done. It should be that. Sorry. Hard enough I'm messing that up too. So it's always x. It's always x. It's domain. Okay? Are we okay so far? All right, now. It's pretty straightforward with a line. Pretty straightforward with a line. So let's do one more with the line, and then I'm going to do parabolas. Okay? So let's look in your book. You can write this out in your book. All right? Y is equal to 3x minus 1. And it asks for determine the y-intercept and x-intercept. Okay. So what's the y-intercept in this case?
Negative 1.
Negative 1. Wrong.
1.
Why?
Reflect it.
Yeah, we
What's the
do
absolute value?
because it's the absolute value. That's why. Okay, so what do we do to find the y-intercept? Put 0 in for x. Agreed? 0 times 3.
0.
Subtract 1. Absolute value plus 1. So there's your first one. Y is equal to 1. There's your y-intercept. What about your x-intercept?
1/3.
Good. Very good. Okay, so what do I do to find the x-intercept? Make y 0, right? Absolute value, so we get rid of it. Okay? Yeah, we can. Okay, so there's a note in here. Let's just read that note. Why was the absolute value symbol removed? What does the absolute value of 0 equal? What's the absolute value of 0? It's just 0. So I can just take that away then. Make it 3x subtract 1. Add 1. Divide by 3. X equal to 1/3. Okay?
Excuse me for the interruption. If any classroom cannot hear announcements or has trouble with the intercom system, please let the office know this morning. Thank you.
All right. Now, I'm going to go back again. Again, I'm going to graph first. I don't like the table of values because I don't really know where to start. Although I do have a starting point right here. But I don't really like to do that. I want to work on graphing first and then table of values from your graph. That's the easiest way to do this. Okay? So, how do I graph 3x subtract 1? What's my y-intercept? So I want to graph this first, and then take the absolute value. So what's my y-intercept? -1 right here. And then where does my map tell me to go? 1, 2, 3, and over 1 to here, right? I've got that right there. Okay. So far so good. So I've graphed this. Now what do I have to do? Reflect. Okay, so this coordinate right here is going to be right there. Agreed? Right there. And there it is. Domain?
Negative infinity to positive infinity.
That's correct. Range?
Y is greater than or equal to 0.
Good. Piecewise. Let's put this together. F of x. What's the equation of the original line? 3x minus 1. And what part of that did I use? Excellent. Okay. The other part I used was this. Right? And what part did I use of that graph?
X is less than the third.
That's pretty easy, right? Okay. The next one. All right. We okay with it, with the line? First of all. So graph the line. Reflect it. Okay. And then you're done. Answer your questions. Domain, range, and then piecewise for that. Okay? Any questions about that so far? Everybody knows how I got these two equations? It's just the original equation. Now, actually, I'm going to explain that before I go any further. I'm going to explain this to you. I want you to see something. Okay? Why is it then I have a positive and a negative? Why is that? Well, the absolute value of x. What does it equal? If it equals 4, what does x equal?
4 or negative 4.
4 or negative 4. We all agree? Because it's in the absolute value bracket here, I have to go x equals 4 and x equals negative 4. Right? I have to understand that there is a positive and a negative value that works in that case. So when it comes to piecewise, that's why I do positive 3x subtract 1 and negative 3x subtract 1. Because when in the absolute value, I'm still going to get the same solution. Is everybody okay? because it's gonna get a little bit more complicated here. All right, so I'm not gonna use the book yet. The book's set up for you to do the calculator, to use the calculator, and I'll show you that in a second, okay? But I'm gonna do one question without the calculator, using the same method I just used. All right? So, y equals the absolute value of x squared subtract 4. Right? What does the graph of y equals x squared subtract 4 look like? What shape is it going to be? It's going to be a parabola, right? Because it's a quadratic. What's the vertex of that?
4 and 0. 0 and 4.
What is it?
0.
0 and what?
Negative 4.
H and K. What's my H value?
0.
What's my K value?
Negative 4.
You remember that? Okay. So again, and I expressed how important it was when we did it. When we do parabolas, we have to have such a massive foundation, okay? Because we're going to use them repeatedly now. And you're going to, at the start of next year, you use them. It's my crutch to go back to always show you how does this graph relate to it. So, y equals x squared subtract 4. 1, 2, 3. There's my negative 4 is my 0, negative 4 is my vertex. We all agree to that? Okay? Got some sleepy heads in here. You guys gotta do the best you can to pay attention. Calculate my x-intercepts. What are my x-intercepts? So what do I do to find x-intercepts? I need my zeros. You're absolutely correct. So I put 0 in for y. We agree? So 0 equals x squared minus 4. Now what?
Plug
X equals what?
in 2 or negative 2.
Okay. That, right? Square root it. Agreed? Difference of squares. X minus 2x plus 2. Gives me negative and plus 2. Got it? Okay. So, that means it's right here and right here. That is all I've ever asked of you. To graph a parabola, get me your vertex, your y-intercept, and your x-intercepts. I've got all 3 in there. All right. Now, how do I show absolute value for this particular graph now? What did I do with the line? After I drew the line, what did I do?
Reflected it.
I reflected it. Do the same thing here. Take all of your negatives for y and reflect them. So what does 0 and negative 4 become?
0 and positive 4.
0 and positive 4. There it is. Just take the bottom and reflect it up. That's all there is to it.
And his bottom.
Pardon me?
Why don't you extend those ones down?
Why don't I extend them down? Because I can't have a negative y.
Oh, yeah.
Correct? Okay, so far? Does that make sense to everybody? So there's unless I have a value counting something outside here like that, I'll never have anything below that line. Okay? If I have this, then I drop it down too. But we're not, that's next year. That's not now. Okay? So that's it. That's how I graph that. Okay? Graph the original. Flip it. What's the domain here?
This is an element of all
What's the range here? Don't let it confuse you. No, don't let it confuse you.
y is greater than or equal to 0.
Done. Right? Still goes up forever. Can't go below 0. But even though there's that hump there, The outsides of it still go up forever. So it's still y is greater than or equal to 0. That doesn't change. Okay? Piecewise, the red is that y equals x squared subtract 4. Okay? That's that graph right here. What part of this graph did I use?
That's greater than 0, equal to.
X, so I used from here out.
Y is greater.
No, I'm not using y at all, because that's range. For my domain, so taking a look at this blue dotted line right here, I used right here and right here.
So negative
Right?
infinity to 2 and 2 to positive infinity.
Yeah, so what do? X is less than or equal to minus 2. X is greater than or equal to 2. Do we agree? Less? Greater than? Right. I think I do. Maybe. I'll check.
If somebody started in 2014 and left.
That might not be any better.
We'll check.
Okay.
That'll be fine.
Okay? So that's what part of my graph, my red graph, that's what I used. Okay? I only used from here out and from here that way. Now, y equals negative x squared subtract 4. And this is the only part that really causes grief in this section, is this piecewise, is understanding it. So this part of the graph is this right here. So what part of that yellow line did I use for the absolute value?
X is greater than negative 2, x is less than positive 2.
Yeah. Negative 2, less than or equal to x, less than or equal to 2. I only used from here to here. And again, I'm only talking the x values. So where are my x values? Right there and there. How far left? Right there. How far right? Right there. Minus 2 is less than or equal to x is less than or equal to 2. Only part that's going to cause you any grief in this section is that piecewise. And I'm really, really concerned about it. Okay? It's good for you to know it. It's good for you to see it. But it's not necessary going ahead that you have to have this down pat. Okay? Questions? All right.
Can we do one more?
Yeah, we're going to do one, and we're going to use a calculator this time. Okay? So, get your calculator out. Before we graph it, so the equation is f of x equals the absolute value of x squared minus 3x minus 4, is that right? Like that.
So
Okay? Now, just wait. We'll get there. Be patient. I said I don't want to graph it just yet. Okay. First things first. What's the y-intercept? Negative 4. Yes or no?
No.
Why?
It's the same absolute value.
So what's the actual y-intercept? Plus 4. Okay? You got that? 0, 0, negative 4, absolute value, plus 4. Fair enough? Okay? Now, we want to find the zeros. Well, we just spent oodles and oodles of time doing this. How do I find the zeros?
Factor it.
Factor it. What's it factored to?
Negative 4 minus 1.
So I've got my y-intercept, I got my x-intercepts. Fair enough? Alright, let's graph it. Y equals. Math. Go to math. Do we see absolute value in there? I don't. Go over 1 to number. Go over 1 to number. See the absolute value there? Yeah?
ABS.
Yeah, ABS. So hit enter. Okay. Now let's put in my equation. X squared minus 3x minus 4. Close the bracket. Hit enter. Don't graph. Don't graph. Don't graph. Just hit enter, please. Okay. So everybody's hit enter on it. All right. Go to your window. Let's change our window. I want my x minimum to be minus 10. Maximum 10. Scale can still be 1. My y minimum minus 10. My x maximum 10. My scale and x res can be 1 as well. Now hit graph, please. Okay. Yeah. So, does it look like the graph we had before? Okay. So, again, let's just talk about it. We'll just put down my intercepts for right now. So my, what did we say my y-intercept was?
Positive 4.
Right there, right? And then my x-intercepts were 4, right there, and negative 1, which is right here. All right, but it's cool if this is halfway in between, but it's not, right? So that's obviously not my bump, because remember, it's symmetrical. So my vertex would have to be somewhere between 4 and negative 1, correct? So here's what we're going to do. We're going to do some work now. Second function, calculate. Maximum value. What's that?
Never mind.
Okay. You all right?
Yeah, no, I just saying something here, so we might interrupt you.
Oh, what was it?
1.5 and 6.25.
1.5 and 6.25. Okay. And go. Yeah, I got that. Okay. Did everybody get the maximum? So left band is just slightly left of that hump. Right? Just slightly right of that hump, and then hit enter, enter. Anybody not get 1.5 and 6.25? That's what I have right there. Your graph is no idea what it needs to do. You use a negative instead of subtract. That's huge. Okay. Okay. And now you do your maximum. All right. It says express as a piecewise. So let's do this one more time. So a positive piecewise, what part of the graph did I use?
X is greater than 4 and x is less than -1.
Okay, sorry, let me just get this all squared away here. What did you have, sorry?
X is greater than 4 and x is less than -1.
Yeah. Greater than or equal to.
Yeah.
On one of them. Doesn't matter which one. Oh, -1, right? Okay. X is greater than 4 or equal to 4. X is less than -1. Good? And then for the negative part of this, what did you use?
X is greater than or equal to -2, x is less, -1, x is less than.
Just like that. Right They should actually both be, there'd be no equals to in this one,
Okay,
because you used your equals to on the top part. It doesn't matter.
that less than should be the greater than.
Less than, no? From here to here, right?
Oh, yeah.
So x is somewhere in between -1 and 4. So that's okay. And actually what I should have done is this should have been equals to. Okay? And you have your calculator to help you for that. We okay? There's not much more to this section. All there is just solving at the end of it. Solving absolute value questions. That's it. Oh, we do reciprocal after, but for absolute value, that's it. There's just 3 things that you have to do. Okay? Any questions about today's stuff? You understand that now? Kind of. Alright. Okay. Today's work starts on page 290. Any questions from yesterday? Yesterday was okay? Breeze through it? Alright, so today, you'll have today to work on it, and probably part of Monday will be to finish that up. Alright?